I just wanted to make a quick video going over some of your questions from the homework. I graded it and all your grades are posted on Blackboard right now. I have my book in front of me, so I'm just going to look at a few of the problems and then solve them out. First, from section 4.2, number 44. Given the values for sine and cosine, use reciprocal and quotient identities to find the values of the other trigonometric functions of t. And we're told sine of t equals 3/4. And cosine of t equals √7/4. All right, using that information, find the other four trigonometric function values. First off, if sine and cosine are both positive, you all did your unit circle, so we should all know which quadrant sine and cosine are both positive in. First quadrant, which means just draw a triangle. Now, by definition, we all know SOHCAHTOA. Just use that and fill in the sides of the triangle. Let's see, sine of t is 3/4. By definition, sine is opposite over hypotenuse, which means on this triangle, if this is my theta right here, sine is opposite over hypotenuse, so the opposite side is 3, the hypotenuse is 4. Cosine of t is √7/4. By definition, cosine is adjacent over hypotenuse, which means the adjacent side is √7, the hypotenuse is 4. And that works well. That tells me I'm doing it right because I got the same hypotenuse for both of them, so everything seems to line up. If you're still not entirely convinced you're correct, do the Pythagorean theorem and make sure it works. In this case, 3 squared plus √7 should equal 4 squared. 3 squared is 9, √7 squared is just 7, 4 squared is 16. And we get 16 equals 16. So all of those sides give me a right triangle that works. But now that I have all three sides, just find the other four trig functions. Let's see. Tangent. Tangent of t, I called it theta here, it doesn't matter. Tangent of t is opposite over adjacent. That's opposite over adjacent. 3 all over √7. One thing I'll point out, a few of you in your homework did not simplify that. Remember, we're not allowed to have a radical in the denominator. So we multiply by √7 on top and bottom. And you get 3√7 all over 7. Next up, let's see, we have cosecant of t. That's a reciprocal trig function. Cosecant is a reciprocal of sine. Sine is opposite over hypotenuse, which means cosecant is hypotenuse over opposite. So that's 4/3. Secant of t. Secant is a reciprocal of cosine. Cosine is adjacent over hypotenuse, which means secant is hypotenuse over adjacent. 4/7. Again, we're not allowed to have a radical in the denominator, so we multiply by √7 on top and bottom. And we get 4√7/7. Last, we have cotangent of t. Tangent is opposite over adjacent, which means cotangent is adjacent over opposite, which would be √7/3. And we're done. Two main points I would point out. One, if you have a radical in the denominator, make sure you simplify it out. I will take off points if you do that for homework or on the exam, so make sure you're getting rid of the radicals in the denominator. The other thing, and we'll see this on the next problem, with the information you're given, always just draw a triangle. You know by SOHCAHTOA what these ratios refer to, opposite over hypotenuse, adjacent over hypotenuse. Plug them into your triangle. The only other thing you have to worry about is the sign of these x and y values, but we know from the unit circle where x is negative, where y is negative. Good. So, the next problem. And I think I need another xy axis. So the next one, number 52. Use an appropriate Pythagorean identity to find the indicated value. So let's see. Given cosecant of t equals negative 41 over 40, for 3 pi over 2 less than t less than 2 pi, find the value of cotangent of t. So let's see. T is between 3 pi over 2 and 2 pi. And we want to find cotangent t. And now, for this, just use your knowledge of right triangles and unit circle. Let's see. Our angle is between 3 pi over 2 and 2 pi. Well, that's 270 degrees, that's 360 degrees, which means my angle is somewhere down here. So, draw a triangle. Call this theta. Your book calls it t, so I guess for this one we'll just call it t. And draw a triangle. Now, use your knowledge of SOHCAHTOA and reciprocal trig identities. Let's see. Cosecant of t is negative 41 over 40. Cosecant is the reciprocal of sine. Sine, SOHCAHTOA, sine is opposite over hypotenuse, which means cosecant is hypotenuse over opposite, which means this is the hypotenuse, this is the opposite. The one trick that goes along with this, your hypotenuse is always a positive number, which means this side, the hypotenuse, always has to be positive. Which means this negative sign goes down here with the 40, which makes sense because it's below the axis. And again, I mentioned this before in another video. Yes, it's a triangle, so it doesn't necessarily make sense to say that a side of the triangle is negative. But when we mention this negative, we're just referring to its value as a trig function when we get there. You don't have to write the negative as long as you understand things on the unit circle, but I just write it so it's clear. But now, if I want to find cotangent of t, well, cotangent, let's see, tangent, SOHCAHTOA. Tangent is opposite over adjacent, which means cotangent is adjacent over opposite. So from here, that's adjacent over opposite. We know the opposite side is negative 40. All we need is this side. But how do you find it? Well, it's a right triangle, Pythagorean theorem. So we get a squared plus negative 40 squared equals 41 squared. A squared plus, let's see, negative 40 squared is 1600. 41 squared. I've done my calculator so we can do it really fast. 41 and 41. It should be 1681, I think. 1, 4, 4, 16. Yep, 1681. Solve for a squared, so subtract the 1600. We get a squared equals 1681 minus 1600, which is 81. And then square root, and a is equal to 9. And there we go. Now, adjacent side is 9, so I get 9. And I'm good to go. You can use an identity for this. Either use a Pythagorean identity, sine squared plus cosine squared equals 1, or alternatively, the reciprocal identities for that we found earlier. But you can just do it with a right triangle. It's essentially the same thing. The last problem I want to go over, let's see. In the next section, 4.3, number 60. A 12-foot ladder leaning against a house makes a 64-degree angle with the ground. Will the ladder reach a windowsill that is 10.5 feet up from the base of the house? So, I think I may have actually already done this in another video, but just in case, we'll do it one more time. So I have a ladder leaning against a house. It's a 12-foot ladder, so I can put 12 feet right there. And I am told it makes an angle of 64 degrees, which means that's 64 degrees. And then the problem says, will the ladder reach a windowsill that is 10.5 feet up from the ground? So we need to draw a windowsill. We'll draw it right here. But we keep in mind, this picture is just a guideline that may not be accurate. It may be further down here or maybe up here. This is just a guide to get us to understand what we're doing. And then that is apparently 10.5 feet off the ground. Now think about what the question is asking. What am I looking for? I want to know if this ladder leaning at that angle will hit this windowsill, which is 10.5 feet up off the ground. So essentially, what do I need to know? How high this ladder goes when it leans. So what I want to find is the height here. Keep in mind, that's not 10.5 feet. That's kind of an extra that we deal with later. I just care about this triangle right here. Some height here, a 12-foot ladder, and a 64-degree angle. Now I can use my trig. Let's see, if that's my theta, that's the opposite side, that's the hypotenuse. Sine is opposite over hypotenuse. So now we can write sine of 64 degrees equals the opposite, which is x, over the hypotenuse, which is 12. Now solve that. Algebraically, I want to get x by itself, so I multiply by 12. And I get 12 sine 64 degrees equals x. One thing I'll point out, when you're doing this for homework or an exam or anything, don't write that as your answer. This is an application, a real world problem, which means I need a numerical answer. If you just leave that, you're not done, you're going to lose credit. So now, throw it into your calculator. Again, I don't have a calculator right here, but just throw it into your calculator, 12 times sine of 64 degrees. Make sure your calculator is set to degrees, not radians. And if you do that, you get x is about 10.8 feet. Now answer the question. Will the ladder at a 64-degree angle reach a windowsill 10.5 feet up? Sure, apparently it'll be 10.8 feet, which means it'll be slightly above the windowsill. There we go. Again, if there's any other questions from other homework problems, let me know. I also posted a discussion board, so you can write your comments there. But if there's any other questions, just ask and I'll make more videos like this.